We're getting close to the end. Once I put it all together, it is a little harder to explain exactly how it works. So I will explain a little bit now, and this is the top, this is the bottom. They will go together, not like, they won't be this tall. It's gonna be about that tall in total, be about that tall. This is the top. We'll pour the alcohol into the top. It will drain into the bottom. So there will be alcohol in the bottom. Because of heat, the alcohol will evaporate. So it'll change from a liquid to a gas. The gas wants to rise. So it rises up the chamber. We are going to have a penny, a peso, covering these holes. So the gas wants to escape, and we've given it places to escape, these holes. I think you can see them more clearly from the inside because of the burrs. I made 16 holes. One of the properties of gas, there's liquids, there's solids, there's gases. Gases want to expand in all directions to fill its container. Compare that to a liquid. A liquid, using gravity, take the shape of its container. It wants to go down, not expand in all directions. But it does want to take the shape of its container and flow downwards. So, back to here. There's liquid alcohol in the bottom. There will be heat, so it'll easily evaporate. So there'll be lots of gaseous alcohol in here, and it will want to escape. It will want to expand, and if there's a place for it to leak out, it will. And that's what the 16 holes are for. We want it to come out these holes. And then after it comes out the holes, that's when it will be burning. And it will look like a gas stove with flames all around it. Our cup will be on top. These two connect to each other by overlapping. So we could put the bottom inside the top, or we could put the top inside the bottom, and they would overlap. There are advantages and disadvantages to both. In total, in my opinion, the advantages favor putting the top on the outside. When the top is on the outside, as the gas expands and wants to fill the container, it's going up. And if it finds a place to leave the container, it will. It will go by the path of least resistance. I really don't like that phrase, but it's a commonly used phrase, a well understood phrase by many people. When the top is on the outside, the gas rises and it finds these holes to just come straight out. The seal between these two pieces will not be perfect. Some people use some special types of tape that can handle high heat. I don't have that. I've never had that, so I've never used that, and it's never mattered. So, especially because I prefer to put the top on the outside, because let's say we know for a fact there is like a major defect in the seal between the two walls, and that there's a hole, a passageway, a hole that is just as large as this one. That's okay, because very little gas will come out of that hole, because watch what happens to happen. Imagine these are now combined. The walls have this much overlap. A liquid is at the bottom of this. As it rises, that would mean going in this direction, it will encounter this hole and want to come out. In our hypothetical situation, we're saying there is another hole here that is between the two walls. So for the gas to come out of that, the gas first has to come up, then it has to go over the wall, this is the inside wall, then down the gap, and then out of the stove, the entire container. The gas doesn't want to do that, because that's not the so-called path of least resistance. There's another issue going on, that the gas is hot. And remember, things that are hot want to rise, and things that are cool generally want to drop because of density. So the direction the gas wants to go is generally upwards, and it is generally moving in that direction. So it wants to come out of this hole rather than make an abrupt U-turn, go down, and then exit. That's the major reason I like putting the top on the outside. One small advantage, putting the bottom on the outside. Remember, you're gonna put liquid in the bottom. If you've got liquid in the bottom and you tilt this, if you tilt it too much, the liquid will spill. When the bottom wall is the one that's on the outside, it's very easy for you to see exactly where the height of the wall is. You can't see the liquid inside, but remembering to not tilt this too far and being able to see exactly where too far is can be useful in limited situations, mostly when the person handling the stove is not particularly experienced with the stove. The other thing I like about having the top on the outside, I mentioned, without more equipment, the seal will not be perfect, but that can actually be an advantage. Remember, hot gases like to go up, and when the hot gas goes up, something needs to take its place. That creates a vacuum effect, or it creates a draft effect, and it drags things along with it. So as the gas inside rises, and then it comes out of these jets, and then it burns, so it gets really hot, so its velocity really increases. That is sucking other air up. Because this seal is not perfect, some of the air that it is sucking up is this air out here, just regular air, not evaporated alcohol. And it's going in the same direction as the alcohol, that it mixes with the alcohol and comes out of the jet. So for those of you who like learning about car engines, that should sound very familiar. That is one of the aspects of internal combustion engine, is combining the fuel with oxygen. Having the wall like this and knowing that it's imperfect, the seal, is an advantage. When the wall is like this, it does not want to suck oxygen-rich air down into it. So there you have it. You don't need to memorize that I think it's best to put the top on the outside. Don't memorize that. Instead, the principles of science that I was just talking about, those are the things that you want to remember. Those are the things you want to understand. Then, if you have to make a beverage can stove, or you have to do anything that is analogous to this, maybe make a fire using different technology. Maybe you are making a fire or a heat source in a shelter, and you want to understand how the air in the shelter will move. The same things I just talked about, the scientific principles I just talked about, would apply. So don't memorize, put the top on the outside. Instead, I went through all that, hoping to highlight the usefulness of all of that science and math that they tried to teach us in school, and that we were like, I'm never gonna use this. And it turns out you can.